Good morning, dear students. How are you? I hope you are fine at your homes and utilizing your time by engaging yourself in different activities. As you know, we are doing chapter magnets. In the last video lecture, you learned about permanent and temporary magnets, and you also learned how to identify between magnetic and non-magnetic materials. Dear students, today you will study about strength of a bar or horseshoe magnet, north and south poles of a bar magnet, interaction, attraction or repulsion between bar magnets. The Tata H video must have provided you sufficient knowledge about the topics. Dear students, after the completion of the topic, you will be able to conclude that strength of a magnet is maximum near its two ends. You will be able to name the two poles of a magnet, and you will be able to demonstrate practically that like poles repel each other and unlike poles attract each other. Strength of a bar or horseshoe magnet. The strength of a magnet can be determined in terms of its attractive force. That is, the force by which materials get attracted towards a magnet. The more is the attractive force, the more will be the pull of the magnet, and the more is the strength of the magnet. Consider a collection of various magnets of different sizes and shapes. Suppose we want to find out the strongest magnet from the given collection. Now, the magnet will be the strongest that attracts large number of metal object towards it. Also, we can draw a bar graph for comparing the strength of different magnets.
Strength of the magnet. For the determination of strength, let's perform a simple activity using bar magnet, circular magnet and some metal clips. Now, I'm taking these magnets . Now see, dear students, the circular magnet is having large number of metal clips than this bar magnet. So, which one is the strongest? That is circular magnet, because large number of metal clips are attached to this magnet. And bar magnet is having only small number of clips attached to its ends. So, the strongest magnet among the two is the circular magnet.
Perform a simple activity to show the strength of bar magnet is maximum near the poles. Take some iron fillings, spread them uniformly on the table and take a bar magnet. Place the bar magnet near the iron fillings. We will observe that most of the iron fillings get attracted towards the ends of a bar magnet, and these ends are called the poles of the magnet. So we conclude that the bar magnet has two ends, and these ends are called poles having maximum strength. You might notice that most of the metallic objects stick at the ends of the magnet. Why? Because the strength of a magnet is maximum near its two ends. The two ends of a magnet are known as its two poles. But the strength of a magnet, it keeps on decreasing as we move towards the middle of the magnet, and at the center, the strength of magnet becomes almost zero. So, the strength of the magnet becomes zero at the center of the magnet. After studying this topic, students, now you can easily conclude that the strength of a magnet is maximum near its two ends, called the poles of the magnet. North and south poles of a bar magnet. When a bar magnet is suspended freely, its two poles point towards the geographical north and south poles. The pole of the bar magnet which points towards the geographical north is called its north pole, and the other which points towards the geographical south is called its south pole. Thus, a magnet has two poles, north pole and south pole. The pole towards geographical north is called north pole and the pole towards geographical south is called south pole. Dear students, now you can name the two poles of the magnet. One is north pole and the other is south pole. Interaction, attraction or repulsion between bar magnets. When the two magnets are placed near each other, either they will repel or attract each other. The forces of interaction between the two magnets depends upon their poles. Now, unlike poles attract each other and like poles repel each other. Dear students, now what do you mean by unlike poles? Unlike poles means that north pole of one bar magnet is facing towards the south pole of other bar magnet. They will attract each other. On the other side, like poles, either both the poles are north poles or south pole, they will repel each other.
Like poles repel each other. North pole of one bar magnet is facing towards the north pole of other bar magnet. So, like pole repel each other. But on other side, unlike poles attract each other. North pole of one bar magnet is facing towards the south pole of other bar magnet. So these are attracting each other. Now this is horseshoe magnet. Again, unlike poles attract each other, north pole of this horseshoe magnet gets attracted towards the south pole of this bar magnet. So again these attract each other.
Thus we conclude that like poles repel each other. For example, north pole it will repel north pole and south pole will repel south pole, means unlike poles repel each other. But on the other side, north pole attract south pole, that means unlike poles attract each other and like poles repel each other. Dear students, after studying today's topic, now you will be able to conclude that the strength of magnet is maximum near its two ends, that is at its poles. You can also name the two poles of the magnet. One is north pole and the other one is south pole. And you can practically demonstrate that like poles repel each other and unlike poles attract each other. Thank you and have a nice day, dear students.